seminar led by Chiara Volta. She's a biogeochemical oceanographer whose research focuses more on carbon cycling, phytoplankton dynamics, and the response of oceanic ecosystem to climate variability. She took her bachelor and master degree at the University of Tuscia in Viterbo, and then she takes a PhD in biogeochemical modeling in Belgium. After that, she moved to for 2 different postdoctoral experience, one in Paris and another one at the University of Hawaii. And from since 2023, she returned back in Italy, and now she works on ENEA Institute, close to Rome, at Casaccia, and close to Rome. And she now is working on Biomass and Physiology, that is a European project, and the Copernicus Climate Data Storage project, and continue to work about Phytoplankton Dynamics and the use of ocean color together and coupled with other observations like mixed layers, SST, and other environmental parameters. So now I pass the floor to Chiara that starts the seminar, and have a good listen.
Okay, good morning everyone. My name is Chiara, and it's my pleasure to be in English. And so I work at the ENEA in the Modelli and Servizi Laboratorio. And today I will talk about this research. It is going to be published in Geophysical Research Letters, which is about the phytoplankton dynamics in the 5 major subtropical gyres. And the study is made through 25 years of satellite observation. So this study came from a collaboration between me and Marco and Salvatore Marullo and the colleagues Xiaoran Xing and Guo Yang from the Second Oceanographic Institute of China. So just to refresh what are the subtropical gyres? So we have 5 major subtropical gyres, one in the north and one in the South Pacific Ocean, one in the north and one in the South Atlantic Ocean, and the 5th is located in the Indian Ocean. So the subtropical gyres are a huge biological desert. As you can see, this is the chlorophyll map, and you can see that inside this system, the chlorophyll concentration is really low. Subtropical gyres are anticyclonic systems that develops between about 10 and 40 degrees in both hemispheres, and they are typically recognized as playing a very important role both in the global carbon cycle and in the global climate system. This is because even if they are really oligotrophic, they are so extended that the phytoplankton activity can play an important role in the carbon budget on global scale. And additionally, they are also very stratified systems, so they can incorporate a lot of heat, and then they can through the circulation they can later release this energy. So as I said, these are typically considered like biological desert. This is because if we can, so this figure show you how the mass transfer to work in these systems. So we have the upwelling of water masses in correspondence of the tropical latitude, and then the water mass move laterally through the towards the subtropical gyres. And this is, so the movement of these water masses also incorporate a lot of material, inorganic, both inorganic and organic. So we will have a strong gradient from the border, from the edge of the systems toward the core. And here, for instance, I found this really interesting figure that they show you. This is a transect, a north-south transect in the Atlantic Ocean and Pacific Ocean. And we can see that in correspondence here of the subtropical latitudes, we have like some kind of bubble where we don't have nutrients almost at all. So this is why we have a very low concentration of nutrient and as a consequence chlorophyll and phytoplankton. Why we start this research? So essentially because there were previous studies showing that the subtropical gyre were already expanding and the oligotrophy was increasing, so the chlorophyll was decreasing. And the previous study also showed like this desertification alert, especially in regards of the role of the subtropical gyre in the climate, in the global climate system. By the way, these studies got some limits, especially because they often rely on 10-year analysis, on less than 10-year time series. So this is really far from the WMO time thresholds. And also, in some cases, well, in two papers, they used a longer time series, but the papers were just focusing on a specific gyre. The most important limit, I guess, is this one. So the chlorophyll was used as proxy for phytoplankton biomass. So this is because people thought biomass, phytoplankton biomass, and chlorophyll were covariant. But this is not true. And this is also been explained very well since 2005 by Barrett et al. And because the chlorophyll A actually is modulated by the availability of nutrients or the temperature or the light conditions. So we can have a decrease in chlorophyll, but also, for instance, the phytoplankton biomass can remain constant, or also it can even increase. So based on this background, we formulated essentially three questions we wanted to answer. So we were interested to see how the desertification was progressing in these systems. So if they were getting larger and becoming more oligotrophic. And we were also interested to see if the decrease in chlorophyll that was previously described also implied decrease phytoplankton biomass. And the third scientific question we want to answer. It's
okay. Was a question about the previous slide. It can be that you have exactly the same amount of chlorophyll, but it's distributed vertically in a different way, so it looks like there is less from satellite.
It's going to be the subject of the next paper. Because this is just using a satellite observation, so we are not sure about what is going on around this. So the third scientific question was to detect what was the most affected area in these systems by oceanic desertification. So to answer these questions, we use a few data sets that cover 25 years from January 1998 to December 2022. And almost all the data sets we use are from other satellites, except the mixed layer depth that was from relied. We worked, as I said before, these systems are characterized by very strong gradients from the edge of the gyre toward the pole. So we just decided to analyze the system on 3 spatial scales. The system scale, that was the entire gyre, that was defined by applying a typical chlorophyll threshold of 0.1 milligram per cubic meter. And then another region that was inside the gyre that was called the oligotrophic region that we defined by applying a chlorophyll threshold of 0.07. And finally, we also decided to analyze the hyperoligotrophic subregion that was defined by applying threshold of 0.04 of chlorophyll concentration. There was just one study analyzing the hyperoligotrophic region that was by Modelli et al. And but we spent a lot sometimes to decide the objective, to define the objective of this subregion, and we finally decided to call it hyperoligotrophic. But if someone has a better idea, I'm open to any suggestion. And we analyzed these 3 special scales, and we saw that each system has a very specific chlorophyll distribution for it that result in the in differences in the average chlorophyll concentrations. For instance, we can see that the lowest chlorophyll concentration was calculated, was observed in the South Pacific gyre. And this is because we had a big contribution of hyperoligotrophic waters. On the other hand, the average chlorophyll concentration was higher in the gyre in the Indian Ocean. This is because almost half of the water masses were characterized by a chlorophyll concentration higher than 0.07. We can also see here that they have different extension, and the gyre in the Pacific Ocean are the most extended, and they almost cover more than 16% of the global ocean. When I write here global scale, I always refer to global ocean, not the global the Earth. So we analyzed the time series of the area, the 3 areas, so the 3 special scales.
Sorry.
Yeah.
So my understanding is that from the label of the table, 25-year averages. So you took the full time series and computed the average, for example, in chlorophyll, of all the pixels that were within the 3 ranges. So there's no, let's say, trend in it.
No, we calculate this is the average, and in the other cases, it's the average by year, the annual average. This is 25-year average.
Okay, yeah, that's the question.
Did I understand well your question? We analyzed the annual average time series for the 3 special scales, and as well the corresponding chlorophyll concentration and sea surface temperature. And well, this figure is really complex to see, but this is the synthesis of the trends. So we saw that on the global scale, always refer to the global ocean, we found that all the subtropical gyres are expanding, and they are also becoming more oligotrophic and warmer. So, and the trend are statistically significant. We also saw by analyzing each system that the most affected area was the hyper-oligotrophic core of this, all the systems we studied. And so we can see that all the systems have a positive trends, and also they are statistically significant. And the corresponding chlorophyll was also decreasing, and the SST was increasing. We also saw that the most impacted system was the hyper-oligotrophic core in the gyre in the North Pacific, where the variation increasing rate for the hyper-oligotrophic core was almost 45% per year. And we also saw that the gyre in the North Atlantic Ocean, they have a lower trend, but they are almost all statistically significant. So, as I said before, one of the most important limits of the previous studies was to use chlorophyll as proxy for to quantify phytoplankton biomass. This is why, because before 2024, there were no algorithm able to quantify the phytoplankton biomass in an accurate way. So why I said until 2024? Because in 2024, Yang et al. Published this. So this is the red square. Published this algorithm that decrease a lot the error associated to these estimates. And in particular, they used this equation where they account for the photoaccumulation, so the influence of nutrients, light, and temperature on both chlorophyll concentration and phytoplankton biomass. But the step forward that Yang et al. Made was also to use this equation and derive the two unknown using non-linear least square regression. And before, typically they use one of these terms as constant. Generally, it was the fraction of non-algo particles. And we can see here that so the yellow dots are the matchups inside the gyre, and we see that this algorithm was not able to be applied in the subtropical gyre, and the other got really a large error associated.
What are the physical dimension of the data?
Theta is
How divided by the state? By
the
No, but the number has limits.
right?
The number has limits.
So 13,000.
Yeah. Yes, that is a scaling factor defined by in-situ measurements in 2005 by Benfeld.
It was used in 2005, but I think it's, yeah.
Yes, so it defined this scaling factor to compare the.
But that works just for chlorophyll up, if I remember well, too short. So
Where point this is after the explanation.
Oh, yeah, sorry. There is another.
And there is a negative dependency from the pi? Negative exponential?
Well, because they arrive at saturation levels and then they decrease. Because there is like, for instance, we have a lot of light, so the phytoplankton cell start to increase, but then they are lead to a saturation and then they start decreasing.
What is the dependency of this nutrient limitation factor? How is this measured generally? So is that associated to one of
It's not very parameterized in connection with temperature and chlorophyll, and it's like a data platform.
yeah, but do you know which data do they use to make this? Is it lab observation?
Oh, no, it's,
Physiological.
But dimensionals. How much do they count the terms?
I'm pretty sure dimensionally speaking,
Which one is the
which one is dominant?
Yeah.
I think it depends on the conditions.
Yes, but if you are in the gyre, or if you are in coastal waters, or I don't know, the southern oceans, or taken, for example, the BB less BB nav, to change if you are in the gyre or if you are in the southern ocean. In the southern ocean, you can have sometimes that the BB nav is equal to the back scattering. Because you have a lot of wind, for example, in the Patagon shelf, there's a lot of non-algal particle, and that could be, that could be equivalent, so it depends.
Anyway, these are not equation that have been created just in the paper, but this come from lab experiment.
yeah,
Photosynthesis curve
Yeah.
and other parameters that describe the photoclinician of that cell.
Yes, they
Yeah.
merge, so wrong, and they merge something that is based on satellite, and double something that is derived from in situ lab measurements.
Yeah, parameterization that already exists actually, and they've been tested in the lab, so.
yeah, actually, also the formulation is from Laboratorio.
Yeah, that's part. The first part, the first step is derived from the paper of Belford of 2005, and the second part is taken from lab experience. That is a common equation. But Dr. said,
All this is made for not overestimate chlorophyll, to not overestimate biomass when chlorophyll is too high as compared to the biomass, and the other way around. Because cells like plants, they adjust the chlorophyll concentration according to light, nutrient, and temperature. And so this is made exactly to modulate this effect, it's a
Yeah,
and we should do something.
May I know so?
yes,
So that's equal to chlorophyll. So the chlorophyll, which is like band ratios, you just discard it. You prefer to use that estimation chlorophyll.
no, I use the chlorophyll from satellite data.
Right.
And then I use this.
Equal to that.
Yeah, and then I use this equation to retrieve
Right.
the biomass.
Okay.
So this is the starting point of the equation, but actually we work on it on the other way around. So we calculate this term by knowing this and this.
As the ratio between
They're using the photoclinician part to
yes.
calibrate the chlorophyll, and so that the local was saying.
It's fixed.
No, but it just to account that phytoplankton carbon is not affected by photoclinician. So it's derived from chlorophyll, but without excluding the impact of
Yes, that's
photoclinician on the chlorophyll value.
That's the point. That's the crucial point, since in the gyre you have the critical issue about the use of chlorophyll, because most of the signal is driven by physiological adaptation of phytoplankton cells to light and environmental condition. So in this way, we can parameterize, we take into account the light in the mixed layer, so the effect of the light in the mixed layer, and how we can, and we exclude this kind of adaptation of photoplankton in the final compilation. It's something that is totally missing in previous work. So,
This came from another paper.
Yes, it's always better because it's the
Bar, the half of the.
yes, in the mixed layer. Try to take into account the attenuation of light in the water column.
Because the point is.
Okay, it's a parameterization. So
Yeah, but the point is that the chlorophyll.
keep in mind.
Square is before the exponential or after the exponential?
Well, remember it's.
Yeah.
But to estimate the biomass, why not use directly BVP and VNAP from satellite?
Because BBNAP, it's
Don't know.
yes, you know, it's usually okay. I'm responding on. Historically, the NAP is defined as being defined as the intercept of the linear fit between chlorophyll and extent. So it's a fraction that doesn't apply to chlorophyll, no? So you have the intercept of the fit. But by using a linear relationship, you cannot really estimate the impact of the physiology in your linear relationship. So linear, so it's to firstly to do the building up and then use not to the right up.
So these are new estimations of living up,
Yeah,
and so you can compare them to your estimations.
yes, in the paper of Bo of Young 2024, and which also normally is involved, we compare the building up with the previous work, and in the gyres, it's more or less the same, but in the experience of mesh up exercise, with all the previous approach like Bell, mine, and I think also compared the graph, JSON graph, yes, probably the empirical relationship in the subtropical gyres, yes, there is not a chance to evaluate the weight of the physiology, and all the statistic forms has a lower performance in terms of retrievals. So the point is that adding this term, the retrievals and attention from space increase in terms of robustness. Okay, consider that this is a great spread of points. Now, I don't know, in the future probably will be other that could be developed to also do, for example, in that case, the BBNAP computation is a map, you can do a monthly scale, so it could be improved, the approach. It's very soft to, but January 2024.
Maybe it's a silly question, but everything is clear. But why using the Barefield definition? Equation. Because I mean, I remember that it was valid just for a chlorophyll above a threshold.
Yes.
So because you are working on ultra-oligotrophic voltage,
Yeah.
it's make you know.
Yeah, I mean, it's from the idea of by Berefeld, but it's a different. And they tested, especially in medium subtropical gyre, and they found like, I mean, this is Berefeld. And this is this one. So you see the error.
Yeah, you add the second part of the equation to Berkeley. This is clear, but the first part, I mean, I remember the paper. I read the paper, but it's 2-3 years ago.
Yes, he included all the value less than 0.1. Yes, but this is not a criteria, no? It's something that, okay, he found the plateau, but the points are average value, monthly average values, values.
There were several cases.
Yes, so, yes, several values.
Yeah.
And also with Gianluca.
Yeah, so I was
we
wondering if this can.
found that there is a variation in cells, scales by region, geographically, temporally.
Yeah,
That's so, but, so,
yeah,
the idea is just the idea. To maintain the idea, then we move from a linear relation to a least square. Just the key point, another critical issue is the scaling factor of 13 clusters. There is no other, actually, there is no other scaling factor again for two.
Yeah, so just wondering,
Just
just wondering if this could affect the results. of the-
yes, this is a carré that in all the paper is a constant, no? Like in paper of 2018, 2024, we say, hey guys, we need to probably invest our effort to try to refine this scaling factor because actually it can have an impact on the final estimation.
So in the tree plot, we're changing the vertical axis. But the horizontal one is the same. Is this?
Yes. You have just one zero Phytoplankton Dynamics. Yes. So the different parameterization and we tested to estimate satellite Phytoplankton carbon using different equation. Actually, in the paper we have tested 4 or 5 methods actually, and then we choose the one that was performing the best. So they were testing different approaches actually.
Yes.
But it's
One order of magnitude.
sorry.
They change one order of magnitude.
Which one?
The view
It's a big-
It change when you move from one to the
Yes,
other.
but if you think that the big,
Well, the biggest one is the P05.
yes, it is actually is one of the most used algorithm actually for studies on a global scales that is ingested in net primary production model that is ingested in ITCC. So that this is something.
Simply because
Who is the?
where does this come from?
So, okay, that's we can pass. Follow.
Not in IPCC though.
Yes, probably.
Although in IPCC models, you generally have mechanistic ways of doing it, so it's not algorithm.
Yes, that's most of the studies are.
We have other issues.
No, because otherwise it's always the community against modelers, it's like models, blah, blah, blah.
But yes, but the net, for example, NASA released for the net primary production data set, and they use. And okay, this is not my paper, but there are so many computations that demonstrate that this is an estimation of 150%.
Actually, this paper that we published in 2024 is what we need to do in general. I mean, there was the first step was verified in 2005, and many other papers, and then we realized that in some water, this is not working because it has its limitations, its assumptions, etc. So we try to move a step forward, applying other parameterization and demonstrating anyway that chlorophyll is not a good proxy for Phytoplankton biomass, at least in some region. And for sure there will be other. There are some limitations. There is also the in situ Phytoplankton carbon dioxide, because this is another problem, is that for getting this kind of in situ data is really like lab consuming. There are no specific funding to do that. And so actually what we are doing now is also facing with some limitation of in situ data that can help to improve more.
There was a limitation about the modeling stuff, algorithm or models, because it's not the perfect representation of the reality. For instance, this equation was tested, we didn't get any data from the Indian Ocean. So we don't know if this algorithm is also able to be applied in the Indian Ocean, which is completely different from the other systems because it's like bordered by lands and there is it's really southern compared to the others, so.
But also, this mixed data set is usually focusing on
the data sets.
waters in which we have a small phytoplankton and not large phytoplankton. And so these make also this application for this kind of areas very well. It's very good because these are areas in which there is no large phytoplankton, at least on the surface. So that for this case study is appropriate as data set. Maybe in a hydrotrophic region, it will not work very well.
Okay, so we use that equation to calculate the phytoplankton biomass, and we compare it with the chlorophyll concentration trends, and we can see that while the chlorophyll concentration is decreasing even significantly in all systems, we don't have the same trend we should expect in terms of phytoplankton biomass, because actually if there was no photoclimation, I would expect if there is a decrease in chlorophyll, I should expect a decrease in phytoplankton biomass. But actually, we sometimes have even an increase, which is statistically significant. But this is, we can go back to the point that in the validation of the algorithm, there were no data, phytoplankton biomass data in the actual. Actually, we don't know if this is real. I mean, these increases. By the way, the idea is that even if the chlorophyll decrease, the phytoplankton biomass is rather constant over time. And so why? Because the phytoplankton community is adapting to new growing conditions. So we also analyzed the trend not only for SST, but also for the mixed layer that and the RG. And also in these cases, we can see that there is no significant trend variation. And also each system reply differently over time. For instance, we have, like, for instance, an increase of RG in the South Atlantic gyre, but we only have like a decrease here in the north part, in the northern part. We also try to find the correlation between chlorophyll and phytoplankton biomass on one hand, and the three physical forces. But again, it looks like each system is working in a specific way, and we cannot find a really clear correlation between among the variables. This is probably because there are other factors that are playing a role in the kind of phytoplankton dynamics in these systems. For instance, variation in the lateral input from the upwelling zone, or I saw there is a paper that has been published like really recently. They account, for instance, for wind. So the turbulence of wind, the effect of the wind turbulence on the phytoplankton dynamics, and especially in terms of decreasing chlorophyll, decreasing of chlorophyll.
So all satellite data are level 4 then?
There are monthly data, right?
No, they
Yeah, but they level 3. So you have somehow the effect of cloud.
Okay, I also like evaluator of this product. This is CCI Ocean Color, and the idea also came because when I was evaluating the merged dataset, we saw that there are no artifacts in
the subtropical gyre. And I'm not speaking about global scale because everybody knows that satellite data don't work at all at the poles, for instance. But here at lower latitude, we have really good, really small error and really good.
If you get the data and you plot the amount of, let's say, valid pixel.
Yeah, we have a lot of politics.
But you have a trend in the valid pixel or
No, it's not trend. I mean, there is like, this is.
You mean in the coverage?
Yeah, in coverage. No, I don't think so.
So
I
let's
saw
for
it.
25 years, you don't have any.
Yeah, sure. I mean, like between 1998 and 2002, I guess. So we just had seaweeds. Yeah. So, but this is accounted by who produced this merger data.
So you are sure that your area coverage is homogeneous.
At the best of our possibilities.
Yeah,
We
don't say, well, yeah, of course, you cannot move the clouds. You feel
No, I
it,
mean,
and you know what?
Gyres, I think this is relatively minor.
Yeah, mine.
And this was a job. No.
Yeah,
It's
That's a secret.
Yeah,
But this is about satellite data. I mean, if we wanna have like this overview, this big overview of this big systems, we just have to go by satellite.
Yeah, no, but just make sure that there is.
None of the trends is driven by.
No, right, yeah.
Because you can also shrink in the geographical coverage due to the field of the clouds.
I don't think it's really related to clouds. I think it's really like the number of satellites that.
Well, that was much easier.
My understanding is that you started from daily data to compute the monthly data over which all the statistics is built.
Yeah, so
So it's monthly data.
yes, you have all the field.
So then we can judge whether 1 month is more representative of another as compared to another of reality.
And I also don't think that
I
clouds
think you do have restrictions.
really important thing is that, I mean, like, if you go toward the poles, yes. We use subtropical latitude,
There are not many clouds.
Yeah, but for this reason, you just need a small change
I think it's.
of clouds and you have a bigger number. If you do not have clouds, when you have clouds, there is a larger effect than if you have always clouds.
There is like non-valid pixels, so if there is clouds, we don't have data.
Yeah, but it's a smaller field.
By counting one.
Smaller now.
In your equation
With
of
an
conservation.
I mean, like, we should, with an average, we like, flatten the anomalies as well.
I think that what Gigi is trying to say is that if you have clouds can impact, so the missing data can impact on your average. So let's say that you have 10 pixels and then 8 pixels are NA because they're covered by cloud. So you do the average just on 2 pixels instead of 10.
Yes, but
So
one
it-
day, 25.
But it, so, but,
Yeah,
yeah,
all
no, but
yes, yes.
this is what, I think that she was talking
I
about.
don't think that's the point in these areas. I mean,
Yeah,
I
because
think
you are-
this point is very important in other,
Yeah, like that.
faults or like,
Maybe what you will do,
Yeah.
what you do with the sensitivity test, if you go back to this, photoplantation equation, where you have this data, you could imagine a sensitivity test of like keeping one fixed and letting the other move, so you can understand the most impactful if it's temperature over R, or if you have this,
I guess they do that.
The equation sounds strange. It means that R is always a negative infinite. So it's better if you don't have R in this equation.
because the.
R is a negative, it's a negative impact on growth.
Negative exponential.
Yeah.
No.
No,
No,
it's
the equation
like-
says-
that's exactly-
It would be better if you don't have R.
No, the point is that
Yeah, that if you read the equation, if you put, but
the way to read,
you
the way
can.
to read that equation is that the more light you have, the less chlorophyll you need.
Yeah.
And the other way around.
But in the dark,
That's the way to read
yeah,
that.
but in the dark would be,
But this is
The
not,
balance-
this is not satellite, passive satellites.
So you
We
just
don't have
have any
any exploration.
yeah, no, but I mean, what is saying that equation, that night is a better condition to have chlorophyll, because PAR is always a negative impact.
Definitely.
Yeah.
It is a better way to have a more precise measurement. Unfortunately, we are unable to measure it at night time, so we have to correct for
We have to
that.
wait.
And that's all.
It's a process equation.
No,
Because
it
it
has
has the
to,
correction.
no, GGF has to do with the more light you have, the less chlorophyll, and the adaptation by itself is pretty fast.
So,
So-
still,
If, it's like, if you have more light, your eyes are.
Yes, it's like an antenna. If you have a lot of light, and you have a lot of.
When you're in the dark, you are like that.
Yeah,
When
but
you are in the.
But you can see also, when you put like your plant in balcony, if there is too much light, they burn.
yeah, but if there is zero, then your plant doesn't exist, and that equation
It's
tells
not
you.
that, that
Yeah,
doesn't.
not exponential.
But it does make.
It's the contribution, it's the contribution though.
so within the cells, you still would have chlorophyll. That's where that.
Yeah.
So,
Question.
Yes. If you go back to the previous slide.
This one?
So, yeah, I'm pretty puzzled by the difference in numbers in the linear trends between chlorophyll and carbon. And apart from the North Atlantic, there's roughly 10%, 20% difference, 25. Oh no, in the Atlantic is but regardless of the precise number, yeah. My question is, so this means that on a global scale, for example, we are roughly 20%
Less. Per year, that's.
per year difference in physiology. So the physiology is playing a role that can be accounted as 20%.
0.20%.
Oh, that's 0.20, sorry.
Yeah,
yearly
So yeah, that was
No, I don't
that's why
think it
I was
does.
kind of puzzled.
The 20%,
Sorry.
well, you would discover if there's something that changed 20% per year in 5 years, you would discover it, I think. Even if you are blind, I mean.
But this means that it decrease in physiology.
We will due to physiology.
Say it again.
The decrease in chlorophyll due to the physiology.
Due to physiology.
Something that would be interesting to disentangle the effect of temperature,
Of the two data.
because this, What is this driven?
Numbers in the equation. To have units and numbers, just to see who is weighting.
because actually it would go the other way around, that, for the adaptation, you would expect higher.
It's not so, it's not so.
So this is sort of like under-regulation. So you're under-regulating your chlorophyll content, right? For example, in the Indian Ocean. So, so this could either be for,
But I think it's like, these systems are very complex, so we can just. Yeah, sure. Probably in the same equation, we should implement a lot of other physical factors.
yeah, but for
I mean,
for
like,
nutrients.
but the nutrients, we have the nutrients.
Yeah.
Because it's affected by this mean, mean.
Yeah, and also the nutrient influence is just based on nitrogen. So we don't have all the other like nutrients that can play a role, iron or something like that. So it's very complex because we play like on both fields, you know, like biological, pretty organic, or like just physical and inorganic.
Especially because the gyres is
Yeah. Nice and.
No,
nice.
But actually,
But it's like always linearly, it's horizontally.
Yeah, but
I mean,
the
it's not
difference whether it's like sensitive or care.
happy.
I'm
Thanks for saying that.
I'm not sure it's.
what you can do now from here,
So, okay, blah, blah, we arrived here.
See you in the.
So, okay, we saw that all the gyre are expanding, becoming more oligotrophic and all warmer. We saw that by Phytoplankton biomass doesn't correspond to the degrees of chlorophyll concentration we saw. So there is like a physiological response of the phytoplankton community to the climate change and the growing changing conditions. And we saw that the most impacted area is the hydrographic core in the North Pacific. And so what's next? Of course, satellite data have big limits that they can see just the surface of the ocean, so we don't know what is going on underwater. So we are wondering what if the climate change and the global warming is also changing the vertical distribution of phytoplankton and chlorophyll, and what would be the effect of these potential changes on phytoplankton productivity and at the end also on the efficiency of the carbon transfer from the atmosphere to the eutrophic zone, not toward the deeper level. That's it.
couple of comments. So,
Let's ask for question also.
Yes,
Yeah.
check if there is some.
I start. So, considering the last comment that of nutrients, I would want to suggest instead of adding complexity to the estimation, that anyway you have estimation, and it's difficult also to validate with in situ, because we need to, in this case, we need lab experiments more than needs to be test anything. I would rather suggest that when you see rather to see because you see that in some regions, in some gyres, there is an increase, significant increase in biomass, while in other there is not. I would rather suggest to use nutrients and other parameters to understand why these are changing. They are different, instead of adding complexity to the algorithm equation, because this will help also to understand the processes that are configuring or not what you are seeing in the analysis. This is my just suggestion. And then the other thing is more a curiosity is, how do you think that you can go deeper or which data are you thinking to use to analyze these things at the same spatial scale?
Any but VR. Don't use VR with Sprite. Sorry.
Yes.
I think there are two answers. We had two answers. Anyone else to expression, but I want to see the answer.
About alboplots or.
Yes, that's a good response.
You go, that's a good
analogy.
Even to go out, as a platform, it's a data set in that for model.
To use that data. Because like from what I know, does apply in the same way in the lab and in the field. So I think what is better, it will be like.
For the lab data, it was just in terms of parameterization because coming to the field of lab experiments in the lab connected to the field, for sure is that it's complex to connect, but at the same time, the lab helps you to disentangle specific behavior. And for instance, for the scaling factor, you need the lab experiments. More than lab experiments, lab analysis. Also from in situ. From samples, you need the first atomic with cell sorting, for instance, and then analysis of the carbon fraction in those specific samples and so other things. And the same is also to parameterize better the phytoplankton, the photosynthesis and brightness equation, and after give you the parameters. So this is why for introducing additional density like nutrients, you need to understand what is the single reaction response to a certain parameter. This is so this is why my suggestion is to move more to understand what is the process that is producing this different trend in the different charts. Because maybe we're using models or other source of data, you can have a more comprehensive view of the environment. Exactly. Yeah, exactly. You can put simulation, for instance, and other things, and so you can have a comprehensive view of what are the parameters that are changing biomass in a region, and why it's not established in another region. So.
Just published. It was like a stochastic model to understand what's the factor that impact more the living like. It is on the global scale, so it's really difficult to understand what's the factor that.
No, you can just do multi-factor regression. Decide what is the dominant or is the predominant, let's say, with respect to the others.
Yeah.
This is not big.
And I think it's also like important to focus on the oligotrophic form because we can assume that it's, well, we saw that it's the most impacted in all systems and also the global scale. And also it's, we can consider it like independent from external mechanism and not like other transmitter mechanisms.
Perhaps I want before leaving. Just to bear in mind that the nutrient contribution to the acclimation, the phytoplankton acclimation to the system, perhaps the organic component of the nutrients that is being shown in the years to play a major role in the gyres, perhaps would be worth to consider. The mineralization of the nutrients and so on. Try to say if you make if you consider a linear fit to compute your theta mean, you use the nitrate and the phosphate, which is, I mean, fair enough, let's say. but you then apply this into a system which is totally nutrient depleted. There's no nitrate and no phosphate at all, especially in the hyper-oligotrophic area. Sorry?
There's no leftover.
Yeah, exactly. There's no leftover, so it's all ammonia, basically, it's not nitrous. So it would be worth to consider this other,
Yeah, it would be nice to see how this data is computed because you would down-regulate if you don't have the nutrients, you would expect to down-regulate because you simply don't have nutrients to build up your chlorophyll.
I guess it's just like it's a bit from that data. I didn't go through because it's pretty common algorithm that we use. The formulation and then the parameters are like slightly different because sometimes these algorithms apply better in a system and not in another system.
Regarding like trying to understand the mechanisms that are behind this, of course, that would be very interesting, but if you don't have these mechanisms somehow in your equation, fiber acclimation equation, then you maybe that's not very helpful anyway. So you can
parlare più forte perché non sta
Alto.
Here is over. My suggestion was for the future work is actually to, because you define this specific carry, no, hyper, oligotrophic, and so on, to compare the Climatici, for example. So to see if there is some specific tax that, and then this can link to the nutrient representation and so on. So having a time series of the Climatici can compare this.
Yeah, there are some.
It's just with models.
Yes, of course, you have to.
I mean, like, not, yeah, but it's very difficult to understand what kind of activity is there.
Eventually, you can just focus on the
I was just one doing.
peak or none.
So the size class.
Yeah.
Yes, there are many charts we have done in the last year and a half, probably. Yes, one idea is to try to understand when we realize that in the hyper-oligotrophic region, not the chlorophyll, it's the variation is mostly due to SSTs and chlorophyll and physiology. Then we actually feel so okay. Now we know this, but maybe this is not maybe this is strictly related to the different size classes or types because it's a change actually for sure. No, like an adaptation to the SST, but also it will normal. I don't know. The Phytoplankton community that dominate the Subtropical Gyres or a group that is now change another one. And this is something that we can do now, okay, from space, probably, and also by modeling.
Like the Darwin model that it's made to do this, like it's based on the size of phytoplankton, so the different P. But however, there are already some results that show that since the nutrients are decreasing, the phytoplankton size is decreasing as well.
Yes.
Because,
I don't know if there is anything about that. Phytoplankton size, unity of types, data sets. But this is sometimes calculated. I don't remember if there is a base about. Yes, that's another.
you mean the change in the phytoplankton functional types.
Yeah, I mean,
It's a mechanistic model source, so you have different phytoplankton times and you see which one wins over the others. This is based on the physiology parameters that is
the size, what it is, the ratio between the size and the volume, that superficie and volume should increase. So actually, because otherwise they should, I mean, less nutrient they have, they should be more capable to incorporate.
Yeah.
But smaller is the ratio between the surface and the volume that should be larger. So this is better in smaller cells, actually.
So in models, this is taken care of when you have a lower house saturation constant, so that they can adapt better and they can take most of the nutrients, low nutrients. And so this is how it's done in a model. I think that's the same. But I have a question for, do you know, so the carbon component, the bacterial part is taken away from this because you subtract this, but is this the BPP NAP changing over time as well? Just curious.
Okay, so in this equation, yeah, it changes over time, but in the previous equation, they will just keep constant, right? Like,
No, it's physics.
Yes.
All the variable, yes,
Not here.
yes, but there is, it's computed by a single climatology, but it takes into account all the variation of SSD, VSD, and along the entire time series. So you have the map of nothing. It is computed. But you can replicate the computation and solve what's going to this case if you want. So you can do this.
So you do account for the change over time here.
The beginning up is a super map.
Okay, so.
Like it's a climatology, so you can incorporate it.
But so here, if you're increasing, let's say that the bacterial component is increasing over time.
Yes, but
Which you don't account.
I don't know, we can trust on the large variations because it's something that you compute pixel scales by using a time series, but it's a data set or that's and there is no validation.
No.
That's it.
But maybe there's also something to look into because I suppose this bacterial component might be because of your
But there are
smaller
some
cells.
studies that show some of the one that we've done by BGC also done and analysis shows that there is variation on the depth of the nap. And also even variations, we have different seasonal cycle and variations in terms of seasonality and monthly scale. So doing internal variations of the nap is a little bit tricky. Because you cannot, but it's probably.
Yeah, no,
Like, okay, there is a brand, okay.
but that would affect your carbon trend.
For the
If you increase
for
the
the reading
pixel.
out, we found also there are some measurements in the footer and also for photometry included. So you can have an idea of what is happening, what is going on in these values because you have concentration of particles out of the measurements. So that is probably.
Can we say your philosophy for yes?
Yes. Okay. People online, do you have any questions?
Still alive.
No question. The discussion was a bit confused from here, but thanks a lot, Chiara. It was interesting.
Okay, Bruno.
Oh, yeah. No, there is also effect on
Use like a constant values or like juries.
it's no, it's not known and it's calculated. Yes, I see here. This is calculated to
Like it's time series variation of nutrient.
I don't know how, but I mean, he account for nutrients limitations, so I guess it's account for the minimum. But
Okay, you use it like as the constant value, is it as the constant value?
no, here, you see, it's not more, okay, which is, I mean, both, it's not a map.
Which is.
Is it speaks, because we got it from satellite data, and then all this, we have this one from satellites. Well, no, this is from an algorithm as well. And then we have Betamax and mean images calculated by the linear regression.
Yeah.
Ok, grazie.
Rispetto ai tassi di variazione, no? Quindi
Domande? No, sì.
Guarda, in realtà adesso il concetto di ESA, in due progetti ESA, in uno ho trovato l'algoritmo, cioè io ho totalità di questo, diciamo, ma l'algoritmo migliore che sembra funzionare a scala globale è l'algoritmo che si chiama
Abbiamo fatto, però
sì,
probabilmente
quindi probabilmente risulterà che quello che i calcoli che stanno facendo sarà
quello che loro l'abbiamo fatto proprio per valutare la
sì,
a sinistra
e invece un altro progetto in cui si verificare Astri dovrebbe fare e anche Astri hanno un altro colpare, cioè però vedo io il carbonio, voglio fare un blend a seconda delle volte carbonio types prendono un algoritmo piuttosto che sono biomateriale non funziona.
Sì, ma comunque è molto
Vai algoritmi per avere un unico migliore possibile a seconda di altri.
no, in realtà no,
Che è collegato ESA, scope, poi per il funding che si ha, che ci sono totalmente altri tecnici officer, hanno fatto, ma è